Good morning. My name is Matt Benoit. I'm the Director of Public Works for the Tellico Village Property Owners Association. We're doing a series of presentations on 5 very important water and sewer projects. And the first project I'd like to start with is a discussion about the elevated water storage tank project. I think the best place to start is, why do you store water? And my answer to that is every distribution system experiences peaks in demand. In order to serve the peak periods, you have to store it and have it available. In the case of Tellico Village, because we're almost exclusively a residential community, our peak demand is tied almost exclusively to irrigation. In the main village, most of the water consumed comes from Loudoun Utilities Board. A small segment in the southern areas of the main village are supplied by TAS, which stands for the Tellico Area Service System. A few facts about irrigation in Tellico Village. In months when we're really not irrigating, so October through April, the main village's purchases an average of 21.8 million gallons a month. In months when irrigation is used, so generally May through September, the main village purchases an average of just under 36.6 gallons a month. That alone, on an average basis, is a 68% increase. But in July, it's almost 47 million gallons a month, which by itself is a 2-time increase over the months when we're not irrigating. So let's continue talking about why you store water. Monthly totals show the magnitude, but it is the daily and hourly totals that more accurately describe the problem. The most recent Jacobs Engineering study, which was developed in early 2021, illustrated LUB's contractual obligation of delivering 4.5 million gallons a day. The same study illustrates TAS's ability to deliver an additional 720,000 gallons per day. Here's where it gets a little bit complicated and hydraulics comes into play. It really isn't a collective pool of 5.3 million gallons a day to draw from, because the TAS water can't be pumped much beyond select neighborhoods in the southern portion of the main village. For most of the main portion of the village, the pool of water to supply demand is somewhere between 4.5 million gallons a day and 5 million gallons a day. Also, keep in mind, demand isn't satisfied on a daily basis because irrigation use is not constant throughout the day. So really, when we're talking about satisfying demand, we have to be aware of what's consumed even on an hourly basis. The same study illustrates 5 million gallons per day equivalent in an hour. Now, I want to be careful to make sure you understand what I'm saying. I'm not suggesting we use up 5 million gallons in an hour. What I'm trying to say is, for select hourly periods during the day, we're using water at a pace of 5 million gallons. So there are periods of time where on an hourly basis, we are very close and maybe exceeding what is available. Where there's a deficit, you have to store that water to meet demand. Another way to look at it is this. If we consume 2/3 of our daily pool of water between 5 a.m. and 9 a.m., we only have about 1/3 available for the remaining 11 hours of daylight. So let's step back for a minute. Some of you are probably saying, wait, Matt, what data do you have that supports an hourly demand problem? Well, that's a great question. The honest answer is we don't really have hourly demand data. Jacobs Engineering built a water model based on monthly data and is using industry engineering standards to project hourly demands. Everything that Tellico Village has available to them is monthly data based on commercial meter reads. So those are the large meters that are assessing how much water is coming through from both the Loudoun Utilities Board and the Tellico Area Service System. So we know what's coming in, and then as we read our household and address specific meters, we know how much is being consumed. The next question is, or should be, shouldn't we resolve the issue of monthly versus hourly data, just to be sure we know what the problem is? That's a great question. And there's about 3 answers to that. Gathering hourly data requires a full change out of all water meters in the main village to install new meters that transmit usage via radio signals on an hourly basis. The estimated cost is about $1.5 million to $2 million, not including the staff time to change out all those meters. It'll take about 9 months to install them and then another summer to collect peak hour data. So I'm trying to illustrate the point that knowing exactly what you're doing on an hourly basis takes a lot of money and a lot of time. And then keep in mind, the water model has its shortcomings. I'm acknowledging them. But that doesn't mean it's wrong. You could very easily spend 18 months switching out all of the meters, then waiting for an additional summer to collect the data, only to really find out you come out with essentially the same conclusion. There are other ways we know we have trouble meeting demand. So let's talk about the other indications of demand. If you consider the chart below that illustrates historical data on the number of single-family homes and the estimated peak daily demand, note how much faster the peak daily demand is growing when compared to single-family growth. So I was able to gather some information both in terms of Jacob studies that were completed in 2017, where we believe we sit in 2024, both in terms of peak daily demand and also the number of single-family homes that were in Tellico Village. What this chart illustrates for you is single-family homes in Tellico Village are growing at a rate of 13 to 20%. The estimated peak daily demand is growing a lot faster than the growth attributed to single-family homes. And I think there's a very simple explanation for that. First of all, as new homes are being installed in Tellico Village, virtually all of them have irrigation systems with them. Once you install a new home, install a new yard, new landscaping, you'll water it pretty considerably to get that grass to grow and the trees to flourish. There's also another issue, which is a lot of single-family homes that didn't used to have irrigation systems are having irrigation systems installed. So I think you can sort of get the point intuitively. Growth and estimated peak demand are not on a linear path. Estimated peak demand is on a much steeper curve than single-family growth. So let's talk some more about the other indications of difficulty meeting demand. It's water pressure. Significant instantaneous demand on a water distribution system is the flu. Water pressure is the symptom. It's like a cough or a sore throat, a sneeze, body aches. Tellico Village sets a standard of 40 pounds per square inch, it's referred to as PSI, as the goal for pressure at your meter. Why 40? Well, most kitchen and shower faucets are designed to operate at a maximum of 60 to 80 PSI. You also have in your home a pressure reducing valve that limits the pressure to probably 45 to 50, maybe as high as 50 PSI. So there are some limiting elements that make 40 kind of a low-end standard. Some lower elevations in our community have pressure over 100 PSI. But using 40 PSI as a standard, you should have adequate pressure for sinks and showers. We know for certain that we are not delivering 40 PSI at the higher elevations in Tellico Village. In the world of symptoms, when we're talking about inadequate pressure to sinks and showers, it's kind of a sneeze or a cough. It's uncomfortable, but it really isn't the end of the world. But there are some bad symptoms, and we should talk about that. We have to meet a state standard for instantaneous flow for fire prevention. Here's how that standard test works. You select a fire hydrant anywhere in the village, and you flow it using an instrument and set that flow, open the fire hydrant, at a rate of 500 gallons per minute. You assess the PCI at the next nearest hydrant. So one is set flowing at 500 gallons per minute, and the next closest has to meet a pressure of 20 psi. Simply put, the state standard is intended to ensure two things. If a fire truck is pulling 500 gallons per minute, can everyone else in the neighborhood still use water? And if there is a significant demand in the neighborhood, can a fire truck even draw 500 gallons a minute for the purpose of adequately fighting a fire? What you really don't want is a fire suppression effort to suck water out of the houses. Now keep in mind, Tellico Village Fire Department has equipment capable of pulling a lot more than 500 gallons a minute. We regularly perform this test to comply with state standards, and we have to report on them. In the higher elevations, we currently pass this test, but barely. Now in the world of symptoms, this issue is not coughing and sneezing. It's a sore throat that keeps you from eating, or body aches that keep you in bed. These types of issues send you to the doctor. So let's summarize this issue of water demand and pressure. And this is something of a crude, non-engineering explanation, but I think it's helpful to understand what it means, particularly with the elevation differences that we have in Tellico Village. So try to imagine, if you can, a water distribution system, sort of like a toilet. The tank on your toilet is storage and holding water for demand. That's the flush. The bowl is all of the homes in Tellico Village at different elevations. When the toilet is flushed, which is instantaneous demand, the water circles down the toilet bowl. And in that instance, who experiences a loss in pressure and availability first? Those are the homes at the highest elevations. But when you consider the chart on growth versus demand, the more demand increases, the more elevations will experience a loss in pressure and availability. So right now, the symptoms are experienced at higher elevations, but the more demand increases, the more the pressure plane, where pressure starts to suffer, will start to experience more and more lower pressures at not just the higher elevations. And everybody will start to experience annoying symptoms, which is not pressure at your kitchen sink or in your shower, but also the bad symptoms of not being able to generate significant fire flow in the event of an emergency. So an elevated water storage tank cures the illness and the symptoms. By constructing a 1 million gallon elevated water storage tank, we accomplish the 500,000 gallons we know we need to store for current demand, plus an additional 500,000 gallons we know we'll need as we transition to build out. By raising the height at which the water is stored by 35 feet above the existing ground storage tank, we generate enough, but not too much, constant pressure to resolve the current pressure plane problems and those that are likely to materialize as additional growth occurs. The estimated cost of the project is $9 million. There are some ancillary improvements, including piping, pumps, valving, and metering, so it's not just $9 million to construct an elevated water storage tank. So I think I'd like to explore some very obvious questions, and I'm going to run through those. First one probably would be, but Matt, if the symptoms only exist at higher elevations, isn't there a more cost-effective solution to curing the problem than an expensive elevated water storage tank? That's a great question, and the answer is no. Jacobs Engineering evaluated the possibility of installing a series of booster pumps on a regional basis and at the higher elevations in some very select areas. Here's a summary of the problems that we identified with that approach. First of all, the estimated cost in 2024 dollars is estimated at $11.5 million versus the $9 million cost for an elevated water storage tank. Second, there's a series of pumps required to boost the pressure. The cost of operating, maintaining, replacing those pumps is an estimated cost of about $1 million more a year than that which is associated with an elevated water storage tank. Booster pumps are just a lot more pieces, parts, components, and things that you have to take care of. The elevated water storage tank has those too, it's just a lot less of them. Tellico Village has been studying this issue since at least 2017. And I really want to point that issue out and make everyone understand we didn't just stumble upon this problem last fall. We have explored a number of different scenarios, both in terms of curing water pressure on a regional neighborhood basis, at various elevations throughout different neighborhoods. And I just want to point out the fact that I wouldn't want you to think that we just stumbled upon this problem and haven't studied all the alternatives. In fact, just yesterday, I was sitting and talking with a couple members of the Public Services Advisory Committee. Even in 2017, we were studying the issue, but in 15 and 16, by their recollection and their involvement, this issue was starting to percolate and starting to become aware to us. And we've been studying it and evaluating alternatives for a long time. So let's talk about some more obvious questions. Won't this additional pressure cause more pipes to break, both in the ground and in my house? The answer is no. Let's talk through that. You should have a pressure reducing valve in your house that limits pressure to your house to 45 to 50 psi. So you don't have to worry about your house. Elevating water storage has a leveling effect of pressure. The pressure will stay more consistent and constant. Stable pressure is better on pipe health than sudden demand. And here's the thing about waterline breaks. We have them now. They break because they get nicked by heavy equipment, they're aging, they may not have been installed to industry standards, and for other unexplained reasons that I don't even necessarily know at the time we have a water leak. Waterline breaks are a random, unpredictable fact of life. The bottom line is, might this additional pressure cause pipes to break? The answer really is maybe, probably not. But effectively, how will we ever know if it was the result of additional pressure on the system? Because pipes don't tell you why they broke. For whatever reason a water line breaks, you can expect the same prompt, courteous, professional, and experienced crew of dedicated public works employees are going to show up and they're going to fix it and they're going to put it back better than the way they found it. So some more obvious questions. Matt, weren't we told that an increase in rates and the construction of a Loudoun Utilities Board elevated tank would solve this issue back in 2022? Yes, you were told that, and it helped. Consider the fact that our pressure issues have maintained relatively consistent throughout. In 2017, we did a Jacobs water model, and it identified pressure problems in various areas within Tellico Village. When we discussed it again in 2021, we were dealing with essentially the same issues. So even during a period of time of intense constructions, we're still dealing with low pressure symptoms at the highest elevations. Intuitively, something prevented things from getting considerably worse. And the one variable that's been introduced into that equation is it must be the LUB tank. So I don't want you to miss the fact that tank helped. It didn't solve all the problems. So Matt, If the LUB storage tank that we were told would solve the problem in 2022 didn't quite solve the problem, then will this elevated water storage tank solve the problem once and for all? That also is a very good question. Our planning for this project takes into account existing platted, so that's individual lot by individual lot properties. It doesn't take into account parcels, which are larger, unplatted properties. Why? Well, in order to account for parcels, the larger unsubdivided pieces of property that have unknown building plans and uncertain density development, you have to start to make some wild predictions about what the water demand would be on those properties. And as you're making those wild predictions, you may also come out with some wild cost estimates to solve that issue. So you have to be careful about how you attempt to account for the unknown. So what's the answer? The issue of growth and balancing infrastructure needs is something every community has to grapple with. It's not new and it's not unique to Tellico Village. Loudoun County is facing some of the same very issues right now. Every proposed parcel, large plot of property development requires its own assessment and review of infrastructure needs. If nothing else, these 5 videos should probably serve as a reminder to all of us that understanding growth and consequences is something we all are going to have to grapple with, and it is not going to start and end with these 5 projects. Another important thing is the Tellico Village Board of Directors is working very hard to adhere to a reserve study to make sure there are adequate funds saved to pay for the maintenance and operation of Tellico Village assets. Growth and money go together. And if you're not planning for growth and planning for your replacement needs, that's where you can get into big trouble. And I believe the Tellico Village Board of Directors is doing a very good job of making sure that we're managing that relationship. So another obvious question that probably exists in your mind is, don't we have an elevated water storage tank now? And the answer is yes, kind of. It isn't elevated, it is a groundwater storage tank, but it's really not high enough and doesn't contain adequate storage. I've got an illustration on the next slide that illustrates the height issue. However, we know from our water modeling studies that we need beyond the current 500,000 gallons of storage that's present in that ground storage tank. And it is evident and estimated that about another 500,000 gallons will be needed. The illustration on the left shows the existing ground storage tank with a ground level elevation of about 1,054. There is a dashed line across it that illustrates the point at which most of the water from LUB comes into the main village. What you can see by that is the top approximately 15 to 20% of the tank is the only portion that provides pressure because it sits high enough to solve the problems we're talking about that are warranted by this new elevated storage tank. The elevation on the right effectively illustrates the bottom of the storage will be just about equal with the top of the existing ground storage tank. We talked about the fact that it'll be about 35 feet higher. And so that's how we know that the existing groundwater storage tank probably isn't going to suffice as we continue to deal with these pressure symptoms. So another obvious question, what's it going to look like? So I've given you a couple of renderings. You can see the elevated water storage tank both on the left and on the right. One's a view of not far from the wellness center. That's the picture on the left. One is a view of what it will look like as you're sort of driving up to the wellness center. It's certainly taller. I hope you wouldn't find it to be obtrusive because we've explained the issue of why we have to put it so high. But those are some illustrations of what we believe it's going to look like. So some more obvious questions. If irrigation drives our demand, and demand is the sickness, can we consider more irrigation restrictions before making this investment? And I'm going to tell you, no, not really. Recall the amount of water increased on a monthly basis during irrigation months is a 2 to 3 time increase. Suffice it to say, if you're going to try to implement irrigation restrictions to deal with that level of increase, you would have to put in place some very significant irrigation restrictions, probably even arguably draconian. So there's 2 ways really to institute a significant irrigation standard that would be needed to curb our demand. The first is to limit irrigation to specific time periods. For instance, an hour a day, spaced throughout the community depending on an address or a neighborhood. Sounds kind of easy, right? Well, the problem is you have to enforce that, which means we will have employees patrolling throughout the day and the night to make sure watering isn't occurring outside the prescribed time periods. There's another drawback. If it works, you'll experience a reduction in revenue, which brings a whole new set of financial problems that really aren't any easier to solve than the issue of a water tank. The second way to institute some really strong irrigation limitations is some painful water rates that effectively make irrigation very expensive. Some of you watching that would say, aren't we there already? The answer is no, they could be stronger. But again, there are 2 very offsetting problems. Some people will let their yards go brown. Now, what you can decide for yourself whether that's a problem or it isn't, but it's an outcome. And again, if and when the financial pain of higher irrigation rates results in enough pain that people modify their behavior and drastically reduce watering, the same revenue problems occur. So when you think about irrigation restrictions, you have to think about it in terms of trading problems. If you don't want the higher water tank, you may introduce some other financial difficulties that are no more fun to deal with than constructing a water tower. So one more obvious question, when will it be done? Probably about 24 to 30 months, starting in March or April. And let me explain that a little bit. We are in the process of designing this. The Tellico Village Board of Directors has contracted for 100% design for the entire project. That's going to take until probably November, December of 2024. Then you kind of have to take a break because you don't ever want to try to bid a project over the holidays. You pretty much have to take a break until at least January 15th to January 30th. So the solution isn't quick. If we continue to add 200 homes each year, the demand issue is going to continue to grow, and the symptom, which we've talked about as pressure, is going to be experienced by more and more villagers. Interestingly, most of what Jacobs Engineering projected for build-out was in the range of 2035. Again, they had to make some assumptions, and they did. The Tellico Village Long Range Planning Committee has made a couple of recent presentations to the board where they're pointing it that build-out is something closer to 2027 or 2028, which is about the time we would have the tower done. So it takes time to solve these problems, and I think I'm illustrating for you the problems are here, they're identifiable, they're quantifiable, and that's why the time is now. Thank you for the opportunity to discuss this. I enjoyed the opportunity to explain these things. I hope you can understand I'm passionate about them. I think they're very important projects, and we do certainly welcome your input.